Alain, a pleasure to have you on the Tech Explosions podcast. How are you today?
Fine, thank you. A pleasure to be here.
It's amazing. So you are in Athens. What is it like now in Athens?
It's gray outside. It's totally not Greece.
Yeah, it's not the picture that I've got in my mind. But you're actually not Greek. You've been in Greece for quite a few years, but you're French, and somehow you ended up in Greece. What happened?
Yeah, it's a bit more complicated. I'm French, as you can tell by the name, but my mother's Canadian, and I live in Greece. So yes, I'm pretty confused. I married a Greek, actually. That's what happened.
You are a citizen of the world.
Exactly, yes. Yeah.
Well, I'm eager to talk about quite a few things because you have a very interesting background. So you have a security background, I think software, right? And then you have, you are an Arduino person, an Arduino maker, a Raspberry Pi, and you are both an entrepreneur and a maker. So tell us a little bit about your background, all that good stuff.
So I'm the founder of a small company called OMZLO that makes manufactures and designs microcontroller systems for makers. It's everything I do is open source, open hardware. But I guess my main product, if you want to call it this way, is called the NoCAN platform. It's an IoT platform for makers. And what sets it apart from all this IoT thing a lot of people are doing is that my platform is wired as opposed to wireless. There's no Wi-Fi, no Bluetooth, and nothing like that. So,
yeah, we'll come back to that because this is the opposite of what the trend is.
Absolutely,
Is
absolutely.
wires. So great. Well, what about
and my background is not at all. My background is not at all electronics. Actually, I come from the world of cryptography. I did a Ph.D. in cryptography. After that, I got into the banking industry, doing smart card security, and then I ended up at what is called the French Data Protection Authority, the CNIL, which it implements a law that protects the privacy of individuals. And I was there as a technical advisor because it's a mix of legal and technical stuff, advising on how privacy of users is sometimes breached or otherwise protected. And then finally today, a few years ago, I joined a company called Cloud Security Alliance that is into best practices for cloud security.
Yeah, CSA. Now, that's quite an interesting background. It's quite far from what you're doing in OMZLO, a company that you founded like last year, I believe, or maybe earlier than that as well. But I think you were actually turned into a proper company last year, and there's a Kickstarter campaign as well. But there's a big distance between all that security stuff and cloud security and government organizations and banks to NoCAN and OMZLO.
Yeah, it's true, but there is in security, and there is always this idea of hacking things.
Tinker.
And there is sometimes, even if we're looking at traditional information systems, there's always a hardware aspect. I remember in my previous job looking at the security of RFID systems that were protecting hospital patients in hospitals that were, very weak, or otherwise they would put some RFID tags on them to make sure that they would not run away, for example. Talking about people who have dementia and stuff like that. And we showed that you could actually still get around these protections by simply putting the tags in metal cans, and then they would not. So you see this idea
transmit.
you cannot transmit anymore. But what I mean is that here again, it's a hacking story. It's about and making is about hacking, and so there's not such a big gap between security and playing with electronics and doing stuff like that.
When it comes to electronics, like you have a PhD in security, so there's a lot of software there, and a lot of your skills come from that formal education that you got through university. When it comes to electronics, is there something similar, or are you totally self-taught there?
I'm totally self-taught. Yes. but what is nice today is that there's so many resources. It's great, everything you can learn online through courses or even YouTube videos. And so I mean, in just a few years I learned a huge amount of things, and I find it very exciting actually that you can do this. It's really great.
So the golden age of self-education. There's no excuse.
Yes.
You can learn anything. So
Yes.
let's start talking about hardware. How did you become acquainted or introduced to things like platforms like the Arduino and the Raspberry Pi? When did it begin?
Well, probably 10 years ago, something like that. I picked up an Arduino, but I probably didn't. I liked to blink an LED, and I liked the idea that you had a platform where you could control everything. I have I love programming, but I love feeling that I control the whole thing. Like
The
it's
real
not.
world.
I don't like when you start playing with 10 layers of abstraction and software and things like that. And I like when you can design things and feel that you can understand pretty much every bit of it. And Arduino at that time, and still today, I guess, but 10 years ago, it was a platform. It was like a mini computer, but you could almost understand everything. And I found that fascinating. But I think I didn't really dig into that until maybe 6 or 7 years ago. It's actually when I moved to Greece, maybe with a change, I decided to dig more into this, and I started a more deeper journey into electronics at that point.
Did you have any projects that got you into, to explore deeper what you can do with the Arduino, or was it at that point more academic? So let's learn how to play with registers.
Well, I was playing. I had this interest in building sensor networks and things like that because I started a family house, and I started looking at gardening and watering, and yes, and track. It sounded like a nice project, but actually, what happened? I started working at that time already on electronics. But what happened is actually we got a lot of burglaries in the neighborhood. And actually, I even saw one literally happening in the neighbors across the street. It's like, like in the movies, I saw some guys with a white bag on their shoulders running out of the house with stuff. And, I started thinking, wow, I mean, this can really happen. It's true. I mean, it's not... And I was thinking, in addition to all the sensors I wanted to start playing with, I could take this opportunity to add a little bit more of surveillance in our own backyard, let's say. And that's maybe the thing that triggered things.
Your background in security is coming out. So
exactly.
How can I use sensors hardware for security, surveillance? So you had the Arduino, you said, okay, I can connect it to sensors, plug it all together, give me some kind of warning system or an alarm or something provides more awareness, right?
Exactly.
And is that like the big project that has followed you for the last 6 or 7 years and that eventually became OMZLO?
I think you could consider it. No, this project started, this thing started maybe 4 years ago. Yes. 3-4 years ago. Before that, no. Yeah, this burglary happened, I think 3 years ago. So that would be the turning point. Yeah. Before that, no, I was just playing with the Arduino from time to time, and also I bought a couple of Raspberry Pis just to. Again, I like the idea of this small computer. Well, it's not true here; it's a real Linux computer, but still, you felt that it was your thing, that you could somehow control it more than these more abstract modern computers. Now, the turning point that led to the creation of OMZLO was probably 3 years ago, 3.5 years ago.
Yeah. Well, let's talk about OMZLO now. I think I'm also going to show my screen to see what it looks like. That's for anybody who is watching this. If you are not watching this and you're listening to us, just go to the website, and the episode page will have a link to the video as well. So So here is the OMZLO homepage, right? So there's a video that shows it, but I can see here from the little diagram that you've got, there's a Raspberry Pi, and that's connected to a bunch of nodes, and they are connected via wire. There's a wire stretching between those nodes. Can you describe what's happening?
Yeah, exactly. Yeah, so this is the really specific thing here is that you have a network, and it's got a gateway that is controlled by a Raspberry Pi, right? And then to that Raspberry Pi you hook up a first node, which is a Arduino compatible node, and then you can add a next one, and then you create a chain like this, and they're all chained together with a single wire. And the Raspberry Pi acts like a gateway between your network and the outside world. And the little nodes together, you can individually program them to do whatever you want. So, for example, you may plug one of the nodes into a relay and that controls a light. You may program another node to measure temperature or humidity, and so on and so forth. And so you have a network of little nodes that you can program, and actually you can program them remotely. You don't need to plug anything into these little nodes. You don't need to physically access them.
So the wire that connects the node to the Raspberry Pi transfers data from sensors and actuators, but also programming information so that you can change its behavior on the fly as it's connected into your house somewhere or your factory. You don't have to go pick it up, bring it back to your desk, reprogram it, and plug it back in.
Exactly, that's exactly it. The wire does two things. It brings power and data. So you don't even have to have little plugs everywhere. You have one wire that takes care of everything. The reason you do this, the reason this is interesting is that if you have sensors in your garden, you don't want to go there, open up a little box, and then program the node. You want, especially if you're a maker and you're always changing and optimizing and creating new things, you don't want to do this.
Cool. That looks really nice. Like, as I was saying earlier, all the rage these days and the trends are to go wireless, but you've gone the other way. You've got a wire that I guess provides a lot of simplicity in the design. You don't have to worry about antennas, radio waves, propagation, and all that. But you've also used an existing technology that has been tried for networks and has been proven to be very reliable, and that is NoCAN, or CAN, I should say, the protocol. Can you tell us about how these nodes communicate based on the protocol?
Yeah, so they use CAN bus, which is it originates in the automobile industry, where you need an extremely reliable network, and then actually a network that has priorities. What I mean is that if you're driving a car and you're switching the radio and pressing the brakes must take priority over switching the radio station. I think it makes sense. And NoCAN actually, CAN bus actually has these priorities embedded in it, and it has a lot of security mechanisms to make sure that every single message is delivered. And it's also designed to be quite resilient in noisy environments, because electrically a car is a very noisy environment.
Yeah.
And they started using it not only in cars, but in boats, and even in very big boats, because it can cover pretty big distances. So for all these reasons, it was a nice fit for what I wanted to do. Another important thing to note is that with CAN bus, every node can decide to speak, if I may say, at any time. In many bus protocols, you have a master who will kind of say, you can speak, and then will nominate the next node that can speak. Here, with CAN bus, any node can speak at any time, which means you really get a real-time design here, and it simplifies things a lot very much. But what we did, what makes it even more special, is that we built a layer on top of CAN bus that adds functionalities that you cannot find typically in CAN bus. I guess we'll talk about it. And that's why it got this kind of joke name. It's called NoCAN because it takes can where no can has ever been.
I was going to ask because I couldn't figure out what the no was. It was like negative or something, like the opposite. But yeah, that makes sense.
Yeah, I know it gets. I thought it was funny when I picked it, but it sometimes confuses people. Maybe not the best choice, but now it has stayed, and you know, it's also a bit of a joke. Like you have no SQL, which is supposed to be the opposite of SQL. You know. Anyway.
So you've got CAN bus that came from the automotive world. It's got like this industrial strength capabilities. It can be used these days in a lot of other settings. It doesn't have to be a car. And you used it to build a system that a maker can build some kind of automation on. Right? And in this setup, the Raspberry Pi is what I guess is the controller, is what provides the logic for what each node is supposed to do. It programs the nodes, it receives data back through interrupts, perhaps. What is the purpose then of the Raspberry Pi in that setting?
So the Raspberry Pi acts, it does network management. One of the, when you plug a node in the network, you can even do it live. Like the node, the network is running, you add a new node, it will say hello, and it will ask for an address. A bit like in, you know, an internet DHCP.
You don't have to switch off and restart. Like that can happen live. Plug in.
Yeah, absolutely.
Node, remove a node. Yep.
Yeah. The Raspberry Pi will actually assign an address to the new node. So it does this kind of network management thing. And then on the other side of things, it acts like a gateway between the network and the outside world, because you can connect this network to outside things, including a smartphone or MQTT, if you're familiar with this, or a REST. There's a RESTful API now. You can address it. You can use command line tools to send messages to your network, and these command line tools can be installed on a completely different computer than the Raspberry Pi. So the Raspberry Pi kind of takes all these things that come from the outside world and sends them to the does a translation, if I may say.
Yeah. So that means that the applications are very diverse, right? It can be mobile applications, that can be centralized, say, server applications. If you want to have like a home security system, I can see here that the ways by which you can interact with the system are also diverse. So you've got a choice of interfaces. What is an example application that like you would propose as like a standard application to begin with for somebody who's learning how to use this in their own settings?
Well, I start actually the temperature and monitoring application is very simple. You just have sensors in different, maybe one inside your house, one outside your house, and you collect temperature and humidity. And you can, for example, send them with MQTT to one of these. There's many today free data collecting websites where you can actually, aggregate the data and do nice graphs. So this is a nice application to visualize how temperature, humidity changes in your house and garden. And potentially, the next step is that you can adapt how you water your plants. And you can use NoCAN to control watering system, switch on and off the water based on this data, for example.
So you need a bit of imagination, but I'm looking here at some of your Python code. So you can use Python to.
This is C. This is Arduino.
Oh, is it C? Oh, Arduino. Yeah, on the Arduino side. Hang on. I'd like to see what's happening on the Raspberry Pi.
There's no code really on the Raspberry Pi.
So do you have some on your website a view of what's happening on the Raspberry Pi? If there's anything that you do on the Raspberry Pi, I imagine how can I configure a node to turn a relay on and off based on some timer, for example. Is that something that I would do on the Raspberry Pi or on my computer via command line connected to the Raspberry Pi?
No, you would do it on a node. The node would be connected to the relay, and you would program. You would write an Arduino sketch, upload it to your node, and then the node, you would tell the node, you know, at a certain time, switch on the relay or whatever. But what gets more interesting is when you have the different nodes that communicate with each other. You could have one node that is measuring the soil humidity, and it would send a message to the network. And then another node could pick it up and say, oh, humidity is below, I don't know what, 100. We should water for half an hour.
Yeah. Right, now I get it. Like, so what the Raspberry Pi is basically to expose the Arduinos, the nodes, the Arduinos to me as a programmer. I interact directly with the nodes.
Yes, yes, yes.
The Raspberry Pi is just a conduit from where that allows me to do this programming and monitoring.
Yeah, because the network is using CAN bus, and most people, you know, are on IP networks, and it's a translation thing. Just translate between, you know, maybe a protocol that works on TCP/IP into something that works on the CAN bus node.
That's very clever. We talked about wireless versus wired a few minutes ago. I think maybe now we should touch into the advantages of one over the other. So obviously, you feel that the wireless option for an application like this, because also you're building a very robust technology, gives you advantages, plus the power. So any disadvantages? Like I can imagine somebody just cutting the wires off, and then your whole system goes offline. Is there any way to, is there any redundancy built in the system? For example, can you do some kind of round loop so that you got communications both ways?
No. It's this approach does exist in some industrial systems. This one you cannot do that. You can, however, detect things. You can, again, it's just there's a lot of flexibility here. You can actually have nodes that ping each other. So if one disappears, at least you will detect it, and you can at least send a notification. And actually, with the latest version of the firmware we have, you really it's I mean, it's an option to flip, but you detect when nodes are unplugged. So you can get an alert for this kind of event.
If there's a fault on a device, is there some fault tolerance so that like the device is the fault is isolated on the device, and then the rest of the nodes can continue to operate?
So yeah, it's a bus. So it means that if one of the devices stops working, it doesn't cut the communication. I mean, if you physically cut with a pair of scissors the cables, of course it's going to stop communication. But let's say if one of the devices you've made a programming mistake and it gets stuck in an infinite loop and it's not doing anything anymore, it's hogging just resources. This will not affect the other nodes, even the ones that are downstream. It has no impact because actually the wires are literally almost going right through the board. I mean, and the device is tapping into these wires.
It's just listening. It doesn't cut into the traffic. Yeah.
If one scenario would be if a node starts going crazy and floods the network with messages, then potentially it could at least slow down communications for sure.
It reminds me of Ethernet, the old days when Ethernet used to operate on a bus, right?
Yes.
Yeah, where the computers connected to the bus would transmit. All computers connected to the same bus would receive all of the transmissions, so that you could have a rogue node that could take over the network, and it's like a denial of service attack back then.
There's a difference, important difference with Ethernet, however, is that Ethernet, literally all nodes can really broadcast at the same time, and there's a complex mechanism to detect collisions and stuff like that. And what happens if a collision happens? You just re-emit, and there's an algorithm called exponential backoff that takes care of, making things work in the end. With CAN bus, it's a more clever system, because actually when two nodes emit at the same time, one automatically takes priority. So there's you never re-emit. You actually, one node stops emitting when it detects the situation, and the message actually usually gets, the one who has priority gets his message through.
How is priority sorted?
Yes. It's, again, it comes to the roots of this protocol. I gave you the example of you hitting the brakes in your car. That node, if it was a node in a network, would have to have absolute priority over everything else. So
there's some kind of number, like a parameter in the setup of each node that provides that information?
Yeah, actually, in the original CAN bus, it's the number. Each node has an identifier, and the lowest identifier has priority.
Yep. Great. Let's switch to your Kickstarter campaign, because that is very interesting as well. So you had this idea to build this about early last year, 2018.
Oh, the idea started a bit, I would say, at least a year before. And even the idea that I did actually a first Kickstarter that failed. What I did initially was this idea, except I used the classic Arduino UNO format, and I used Atmel 328. So I was, and I did it also. I mean, in a Kickstarter, there's a lot of things that you don't know when you do your first Kickstarter. You know, how you advertise it, how you use social media and all that. And I had no experience with my first Kickstarter, so it failed maybe because of some technical aspect of the project, but also I think because I didn't have the experience, basically.
Yeah. But second time around, it actually did well, and the project got funded, right? And
absolutely,
it's what we're looking at now.
Yeah, absolutely, yes.
So we talked about that in October. Yeah.
Just I want to mention on the topic, before I forget, on the topic of redundancy, you were asking. One aspect of this design that is interesting is that in reality, every node has two microcontrollers. It has a main microcontroller, which is an Arduino compatible one, ARM Cortex, so like all the modern Arduinos have that. But it has a second chip, which is also a microcontroller, that is capable of resetting the first one. And this is very important like a watchdog, which means that if in practice you write an Arduino sketch that does something wrong, gets stuck in an infinite loop, you can instruct the second chip to reset the first one. The idea again is that if there's a problem, you don't want to go back at the in your garden, open up a box and plug in a USB or something like that. This guarantees that you will be able to recover from this kind of issue, which is very important.
So you can see the two microcontrollers here. So you got an SAMD21. Is this like the main microcontroller that runs your program?
Yes, absolutely.
Yeah. And this one here
is an STM32F0.
Yeah. So this is the watchdog. Make sure that this one's doing its job. Yeah. And
it's actually also, this watchdog also does the CAN bus stuff.
Right.
Yeah, and, because
I was looking at the layout here of the board, which is this is your designs, totally your designs, part of the campaign, and there's also the hat that goes onto the Raspberry Pi. That is also your design, part of the campaign, right? So all these pins are available to the makers, to the maker, to attach devices and sensors and actuators, right? And your inputs, outputs, or the connections to the CAN bus is just these 4 pins.
No, it's the green headers, the green.
Oh yeah, right.
Yes, yeah. This is an extra. This is an extra for programming and testing purposes, but I left it there. So if people, people sometimes have imagination, they could potentially add on top, like a hat or what? Not a hat, a shield that would use this and connect.
Right. And the signals that you get from the green plugs, the green ports here, go through to those 4 pins so that you can extend it yourself with a hat on the hat. Yeah.
Exactly.
Cool. Very clever. It's really nice.
And the board is actually my design, but the format is the Arduino MKR format, which is their today it's their new line. The new line of Arduinos follow the MKR format, which is like you see on the screen, 61.5 millimeters by I guess an inch, and it's and the pins on the CAN 0 are exactly the same the same pin out as on the MKR 0 from Arduino. So any shield that works on one will work on the other. So it's true, I designed this independently, but I mean, I really wanted this to be compatible with things that exist out there.
Yeah, you drew from the platform. It makes sense because you program it in Arduino, and you might as well keep all the compatibilities of the ecosystem there.
Absolutely.
So you assembled all this yourself, right? In your
house. Yes.
From the campaign on Kickstarter. Tell us about that experience. There's a lot of soldering here. There's small components.
Yes. Look, this is something you don't realize necessarily when you do the Kickstarter. Is that I don't know. I made 600 boards. I have now a whole setup to take care of this. But yeah, there is a lot of things that can go wrong when you're doing a certain volume. Like it's easy to make 5 boards. It's easy to make 10 boards, but when you pass 100, a lot of things you didn't expect. You will get some boards that don't work, and you have no idea why. Maybe 1% of the boards don't work. You will get problems that again, it's the more you make, like. Some parts just don't land correctly on they flip around in the oven when you reflow. There's so many things that can happen, and so it's not as easy as it sounds. You have a lot of extra work to do to get high quality production.
So you assembled all these. I guess you got the PCBs manufactured in China, perhaps. You get the PCBs back, but all these components you assembled yourself. You had a reflow oven, your stencils.
Yes.
Did you
and I have a small pick and place machine. No. I have a small pick and place machine.
Yeah.
Chinese, one of these Chinese popular pick and place machines. It's a Neoden, actually. It's called. The problem with these machines is that they're not. There's a big learning curve, a big one. And they're not 100% reliable. They work quite well once you get the hang of them, but I would say it takes a full Kickstarter campaign to get a good understanding of how the machine works.
Gee, well, it must have been backbreaking, to say the least.
Yes.
I see here that you got your lesson that testing is the key, and you've built your own rigs or jig. So,
yes, it's something actually you need to think about when you design the product. Actually, test. Ideally, but ideally never happens. You should design the testing board at the same time as you're designing the product in parallel. In reality, it doesn't happen this way, but that's how you should do it. Yeah.
Well, you mentioned the design phase. So in your case here, your design was essentially dictated by the shape and the characteristics of the MKR 1000, the Arduino.
Yes.
It had that right shape, but everything else, like the layout of the components on it, which components, where they would go, and their orientation, all those were really up to you, right? And the interface, the in and out for the CAN bus. Did you, apart from functional considerations, when you were designing these, were you thinking about manufacturing and then testing, or is it something that you learned towards the end?
Yeah, I mean, I was thinking about, I mean, you read a lot of articles about designing for manufacturability or something like that, and they tell you, you get a few tips and things like that, but actually you don't really know until you actually make them. There's something that, you know, it's really with experience that you understand how some things just don't play out or work well, you know.
Learn by doing.
Exactly, yes.
It's all about
That's what
learning.
being a maker is about, isn't it?
Yeah, it's the best kind of learning. Like
Yes.
you had to ship all these boards out, and
Mm-hmm.
you learned a lot about how the shipping industry works, like the postal services, and
Yeah, actually, unfortunately, Greece is not, as a country, as an economy, it's turned very much to an internal things like, you know, uh, Greece is great for hotels and restaurants and, you know, tourism, but it's not, the country is a bit, compared to other countries, I would say in the EU, it's a bit in the, like 20 years in the past when it comes to shipping stuff and
yeah.
importing things and, but you know, like no country is perfect. You have to just learn all these things as you go.
So you need, like, as an entrepreneur and a Kickstarter person, having completed successfully a Kickstarter campaign, there's a few things that you really need to think carefully before, I guess, before you even attempt to get on it. It's not like you're going to be able to design everything in perfection, but there's going to be manufacturing, there's going to be marketing, there's going to be shipping, especially if you're shipping like a physical product, and
Hmm.
you've got to be very careful with your financials, like what you got to make sure that you stay within your budget. And did you have any such problems in particular with your budget?
The budget was generally okay. You get a few surprises, but overall, no, I was within budget. Especially because the campaign was successful. I even went a bit over the the the, the goal I had set. So I
Yeah.
was not, you know, in a situation where you're just going by the numbers. I had a bit of extra space, which was nice. But to get to the Kickstarter, I made several prototypes. It's not like I designed the board and magically it worked. There was like probably 20 prototypes before I got there. So, you know, it's
So
not.
from a technical perspective, then you really didn't have any risk, right? You knew that you could deliver it.
Yeah, I was my nightmare is, and it still is sometimes, is that the product is out there and there's a flaw that I did not see, and it affects all the boards, and I would have to, you know, I don't know,
Redo
nothing
them.
works anymore. Yeah, yeah, I don't
Yeah,
know.
that is terrifying. Yeah, but it's been a while, so I think if there had been any problems like that, like that'd be out now, that'd be surfaced.
I've had actually a moment of adrenaline once. I got because I get feedback from users on our message boards and stuff like that, and um, I got one day a message from someone saying that he had trouble using several channels. So I mean, yeah, the NoCAN system works with communicates with channels. Something I forgot to mention, like boards, the nodes. They create a channel, give it a name. Like, for example, you would have a channel called temperature, and you publish the temperature on that channel. There's no address. There's no. It's not like in TCP. You don't send it to a specific node.
Oh,
You kind
it's
of
like
share it with everybody, and everybody who
MQTT, right?
subscribe to what? Sorry.
It sounds like MQTT channels.
Exactly. It's absolutely the same thing. It's like MQTT. So anyway, but this, as a parenthesis, this makes programming much easier because you don't have to think
Yeah.
about if a node exists. In some cases, you can write code that will work even before some nodes are plugged in the network, because you know you just publish to a channel, and if new nodes start getting interest in that channel, they will receive the messages. Anyway, I see a message in the forum, someone telling me that he cannot send messages with several channels, and I mean, this would a huge flaw, and I test it. I do his test case, and he's right. And I freeze because I'm thinking, I have, I don't know, 400 or 500 boards out there, and they have a major flaw, and it's just a nightmare. So for an hour, I'm like, and it
Talk to
turns
me right
out
now.
it turns out that there was a flaw. An upgrade of the Arduino library contained a mistake, and that caused it was not a flaw in the hardware or in the firmware that was on that hardware, which is the most
Yeah.
the biggest problem. It was a flaw in the Arduino library, and an update of the Arduino library fixed it. Thank God.
I had a similar experience with what you're describing a couple of days ago when I'm working on like a little project here with an ESP32. I ran the same sketch on this as I did about a month ago. A month ago, it ran flawlessly. 2 days ago, when I did the same thing, it wouldn't compile. And it turns out that it was an update, I think, of the platform IO firmware, like the next version up, which caused one of the libraries in my project to not compile. And just like you, it took me about an hour to realize what was happening. And because it was a very new flaw, there was nothing on the internet about it. So even worse. So know exactly what you mean. And I think it's one of the consequences of using open source software that shares a lot of software from a lot of different places, and all those things essentially operate independently. And there's no way for the authors really to test the new version of their software against every possible combination of software that end users might be playing around with. So something to keep in mind.
Yes.
What's happening in this year? Like, what's your plan for NoCAN? Where is it going?
There are a few things that we wanted to do, and we did. Actually, MQTT compatibility has been added, web interface. What I would like to do now is there is a RESTful API, but it's not documented. So this is hopefully going to happen pretty soon. And I would like to have some Python code, Python library that allows you to interact with the NoCAN network. Because I was telling you before that the ideal is to put all the logic in the nodes, so one node reacts to the other. But I have some use cases where people would have nodes that are doing some things, but they want to take decisions, for example, on the Raspberry Pi, or even on another computer. And this means that they want to write a sketch, and Python is quite ideal for this, where they say, oh, if this sensor does this and this sensor does that, I should do this extra thing, I should send another message to the network. So they want to put some of the brains outside of the network, which makes sense actually. And so providing Python bindings to NoCAN would be helpful. This is a feature request I've had for a while, and this is something I want to look into.
The hardware itself remains as it is. What you're talking about are end user improvements in the software side.
Yes.
Yeah.
On the hardware side, things will. For now, things will stay as they are because it works actually.
Yeah. So you want to just make it even more useful and make it an appropriate technology for a greater variety of applications.
Yes.
Yeah. Well, Alain, let's wrap it up. What advice would you give to our listeners and to our viewers who are like you, perhaps, say, 10 years ago, when you started playing around with the Arduino, with the Raspberry Pi, with hardware? They came from a different area, not necessarily hardware. How do they start?
I think pick a project, like I did actually, And of course, a big project can be scary, but you break it down into smaller pieces, and you first prove yourself that you can do the very small bits, and then you get them together, and you will, I guess, you will make mistakes. You will do some things that are completely wrong, and it will take time, but it's totally worth it. The way to learn is to try to make things. And take advantage of the huge amount of resources you can get today, online courses, YouTube videos, and online. Some universities are even providing free courses on electronics. It's just fantastic what you can do today, and not to be scared, because I still, and because I was late. I didn't study electrical engineering. I was late in the game, I can say.
Yeah.
I still remember how intimidated I was when I first soldered things. You know, I was thinking, my God, there's no way I'm going to do anything bigger than this. It's already, I can't even solder correctly. It's awful. What I'm doing is, you know, it's ugly. But believe me, you learn, and you know, I guess as well, you learn and you can progress, and it's amazing what you can achieve if you just take the time to try to make things.
Yeah, like your first project was a blinking LED on an Arduino, and then you ended up shipping out 700 boards of your design, software, hardware, ground up, with your pick-and-place machine, your reflow oven, a Kickstarter campaign a few years later, right? It didn't just happen. It's just a gradual, I guess, improving of your skills, your capabilities as you go. But it started with the blinking LED.
Yeah.
Awesome. Well, it was a pleasure having you on the Tech Explorations podcast, Alain.
Thank you for having me. It was great.
So I'll be looking forward to your updates in 2019, because I do have one of your kits with me that I'm going to play with. I hope I can produce an interesting project that can match, that is worthy of being on your blog sometime sooner than later. So
okay, great. I'm looking forward to that. Great.